My name is Kucek, and I'm a graduate researcher at Cornell University, and a lot of my research works with participatory breeding, and so it's an honor to be among such wonderful colleagues doing innovative work. But I'm going to take a slight detour from that subject today to answer a question that I frequently receive from the farmers and the bakers and the consumers with whom I work in my work, and that is, what varieties and species of wheat are better for me, for my health, and have better gluten. So can I just see a show of hands in the room if you have a family member or a close friend or yourself that are on a gluten-free diet? Yeah, almost everyone in the room, it looks like. And this is a really hot topic in popular culture right now, but I feel like the public often has really biased information that isn't very correct out there. So we have gluten-free diet promoters that call modern wheat a perfect chronic poison, and we have the wheat industry that has generally kind of ignored the issue, saying that wheat gluten isn't bad. And so I undertook a review of the scientific literature to see what first are the different disease pathologies caused by wheat in the human body, and then second, how wheat sensitivity varies by different species and varieties of wheat, and then finally to see how processing methods impact wheat sensitivity. So first, what are the sensitivities caused by wheat in the body? Celiac disease is a chronic autoimmune disorder that can be manifested in individuals genetically predisposed to the disease. It is diagnosed through villus atrophy in the intestine, and it is associated with symptoms such as poor nutrient absorption, such as weight loss, diarrhea, and pain. And celiac disease, although overall we probably don't know how many people are impacted, and there's probably a lot more incidence of the disease out there than we know. It is the most prevalent genetically related autoimmune disorder in the world, affecting about 0.5 to 2% of different populations around the world. And celiac disease is triggered by the consumption of wheat proteins, and in particular, alpha and omega gliadins, which are a type of gluten, and amylase trypsin inhibitors, which are not gluten. They're another protein, and I'll discuss those in depth a little bit further on in the presentation. So in individuals with wheat allergy, proteins in wheat bind to IgEs to produce histamines and other chemical mediators of allergies. And there's different pathologies that individuals with wheat allergies demonstrate. The first is baker's asthma or rhinitis, in which the inhalation of wheat causes, wheat flour that is, causes the reaction. And others with atopic dermatitis, which are predominantly children, after internal exposure with wheat, they'll have skin irritation that appears. Individuals with urticaria get hives after eating wheat. And finally, the most dangerous form of wheat allergy, which is anaphylaxis, is a whole body immune reaction to wheat. And as a global average, wheat allergy affects 0.4% of the population, and wheat is one of the top 8 food allergens in the world. And it's caused by a wide diversity of different proteins in wheat, and different types of allergy are often triggered by different proteins within the wheat. And for anaphylaxis and urticaria, it's predominantly caused by one very specific protein in wheat that's called the omega-5 gliadins. So next, and of kind of most discussion in popular culture, if someone notices that wheat causes problems for them in their diet, but they are not diagnosed with celiac disease or with wheat allergy, they fall in this other category that's kind of ill-defined, but the medical field calls it non-celiac wheat sensitivity, and the general public often calls it gluten intolerance. And we don't really know what's happening. We haven't cracked the case on this of what's going on, but we do have a few suspects about what might be happening. So I'm going to introduce you to those suspects. The first suspect might not be wheat. So a large study conducted by Corrosio and colleagues in 2012 looked at about 1,000 patients that were diagnosed with non-celiac wheat sensitivity. And of those patients, when they removed wheat from the diet and then reintroduced it, 70% of individuals did not get their symptoms reduced and then reintroduced. So wheat may not have been causing those symptoms. But of the 30% of individuals who did respond to wheat in their diet, the majority just had a general hypersensitivity, similar to allergy, to wheat in addition to a broad array of many different food types. And a minority of that 30% had a celiac-like reaction mechanism in their body. So celiac disease is kind of proposed to be a spectrum of intensity, and to have villus atrophy, you have to have this particular diagnostic that's somewhere along the spectrum. And so if people have something going on like celiac disease in their body after eating wheat, but it's not intense enough on this spectrum to be defined as celiac disease, they could have non-celiac wheat sensitivity. Amylase trypsin inhibitors that I mentioned earlier with celiac disease and with wheat allergy are also a potential suspect in non-celiac wheat sensitivity. So these amylase trypsin inhibitors are defense compounds that the wheat kernel produces to protect it from getting eaten. So the wheat kernel has this protein within it that when insects, when animals, including humans, eat the grain, these proteins can get to work to prevent those pests from being able to digest the glycogen and the starch within the grain. And so some of these amylase trypsin inhibitors directly prevent our ability to digest the grain. And their studies have shown that amylase trypsin inhibitors increase intestinal inflammation in individuals without celiac disease. And then finally, fructans may be implicated in non-celiac wheat sensitivity. These are not proteins. So everything I've talked about up to this point is a protein found within wheat, but fructans are not. They are polymers of fructose, a sugar, that are found in wheat, and they help the wheat plant resist drought and cold. They're kind of like antifreeze within the wheat plant. And these fructans, when we digest them, they act as what some people call a prebiotic and dietary fiber because we cannot break them apart in our digestive system. And so they go to our large intestine where microbes break it down for us. And so those microbes can also produce gas in the process of doing that. And so while this is a great dietary fiber and prebiotic in our diet, if fructans are eaten more than 15 grams per day, most people will find discomfort from gas and bloating and things like that in their diet. And fructans are part of a larger group of carbohydrates that are fermentable within our system that are called FODMAPs. And these FODMAPs are found in many different foods. They're in lactose and dairy, they're in sorbitol from stone fruits, and they're in raffinose that are in legumes and the cabbage family as well. And so these FODMAPs produce that same effect in the large intestine. And studies looked at individuals with non-celiac wheat sensitivity, and when they reduced the total amount of FODMAPs, these fermentable carbohydrates in the diet, people found a reduction in symptoms. So going back to the 70% of people who did not respond when wheat was taken out of the diet, it's possible that if all FODMAPs had been reduced in their diet, they may have seen an improvement of symptoms. But it's important for people with non-celiac wheat sensitivity to find out what is causing their symptoms so that they can create a diet that actually helps them, that reducing wheat may not actually help all of their symptoms if these FODMAPs with high amounts of fructans and other fermentable carbohydrates are really what are causing the issue. So another documented and well understood condition that is caused by wheat is fructose malabsorption. So in individuals with fructose malabsorption, when they eat fructose, they do not properly absorb that within their digestive tract. And it again goes to the large intestine where it creates lots of gas, lots of bloating, lots of discomfort. And it's potentially quite a large percentage of the population that is impacted by this. And fructans, again, within wheat, are polymers of fructose. And so they act the same way for individuals that are unable to absorb free fructose. And finally, irritable bowel syndrome, which affects a large portion of the population. 11.5% of Europeans and 14.1% of individuals from the United States have irritable bowel syndrome, which I'll refer to as IBS. And in these individuals, it's very similar to fructose malabsorption. They cannot absorb this fructose or fructans very well, and so they experience that same gastrointestinal discomfort from eating wheat, in addition to a broad array of other foods that contain fructose. So the question is, how do these wheat sensitivities vary after eating different varieties and species of wheat? So I'm going to give you some wheat family history here. So in the bottom right-hand corner, this is common wheat, also known as bread wheat, hexaploid wheat. It's the wheat that we generally eat in our diet. And it is made up of 3 different genomes, the A, the B, and the D, that are derived from different ancestors. And so if we go furthest back in time, we find cultivated einkorn, which only has the A genome of wheat. And then moving on to emmer, durum, and rivet, they share both the A and the B genomes with wheat. And then finally, spelt has the A, the B, and the D genomes of wheat. So each of these species of wheat will produce different types and amounts of those compounds that are problematic for people with celiac and with wheat sensitivities of all types. And within each species, there is high variability among different genotypes for these production of different proteins and fructans that can be problematic as well. So I looked at all of the studies I could find out there, and this is kind of a meta-analysis that I'll go through of these different studies. So this graph, which is, I'll guide you through it because it's a bit complex, shows the results from 7 different studies that looked at the intensity of celiac response, which is indicated in orange here, or the content of highly reactive alpha-gliadins, which is indicated in gray, from different species and different varieties within those species of wheat. And each box stretches from the minimum value reported in the literature to the maximum value. And then the dark bars show the means across all of the different studies for each of these species. And we can see here I've separated common wheat into 2 different categories. So modern wheat defines the varieties of wheat that were developed after the creation of dwarfing genes in the 1950s, and heritage wheat kind of contains those older varieties that were developed before 1950. So a lot of these problematic proteins for individuals with celiac disease are encoded by the D genome of wheat. And so we can see that spelt and common wheat, both modern and heritage, all produce, on average, a similar amount of these difficult compounds and problematic compounds for people with celiac disease, because they all share the D genome. But moving on, durum and emmer, on average, had a lower amount of production of these alpha-gliadin compounds, but also a lower amount of intensity of celiac response in vitro or in vivo than common wheat. But einkorn here on the left-hand side is probably the most promising for producing low to no effects in different individuals with celiac disease. So as far as allergies go, for anaphylaxis and urticaria, which are often seen as, the most dangerous forms of wheat allergy, the omega-5 gliadins that are problematic in this situation are encoded by the B genome of wheat in particular, but all species of wheat that were evaluated, so einkorn, emmer, durum, spelt, and modern wheat, all produced those compounds. So that's important to know. But there's large variability among different varieties of wheat that are out there. So these few studies that I looked at evaluated 19 different cultivars of modern wheat, and there was about a 10-fold difference in production of these omega-5 gliadins among those different varieties. So there is promise of hypoallergenic varieties that already exist that produce low amounts of this. And then looking at all allergies as a whole, this is IgE binding, which is a measure of allergenicity within the grain. And this shows that there are some varieties of spelt that have been identified as being hypoallergenic, and on average spelt had lower IgE binding, but there are some varieties of spelt that are quite high, and even more so than other modern wheats. So variety selection is very important among all of these. And you would notice as well on the previous chart of celiac disease, there were varieties of durum that produced amounts of alpha-gliadin epitopes that were higher than any common wheat that was evaluated. So again, variety selection is very important, and just selecting a particular species does not mean that that's going to be better for you. Okay. So amylase trypsin inhibitors, again, are problematic for a wide range of different wheat sensitivities, including celiac disease, allergies, and non-celiac wheat sensitivity. And these amylase trypsin inhibitors are protecting the grain from being eaten, and they're encoded by the B and the D genomes of wheat. And einkorn is looking very promising, as you see here, for producing little to no effect of these amylase trypsin inhibitors on humans. So fructans, which are problematic for individuals with non-celiac disease, irritable bowel syndrome, and fructose malabsorption. We don't have much data out there for different species of wheat. So as you can see here, these N numbers show the amount of varieties that have been evaluated in the literature, and there's not much to hold on to here. But as far as wheat goes, there's really wide range of variability among the several hundred cultivars that have been studied. And so we do have varieties available with low amounts of fructan expression. So what do we take out of this as plant breeders and consumers? I think there are obviously a great place to start is doing screening for this. The data show that there are existing varieties of wheat that have low expression of these difficult and problematic compounds within wheat, so we can identify those and encourage production of those for certain populations. But we can also breed for reduced problematic compounds within wheat. And a good example is omega-5 gliadins. There has already been a variety developed, as you see in this paper, that has very low omega-5 gliadin content for individuals with wheat allergy. And I think ATIs in particular are a great breeding target because there are many different wheat sensitivities that react to these amylase trypsin inhibitors. However, the amylase trypsin inhibitors are kind of a natural defense within the wheat grain against post-harvest infestation. And so we'll have to make sure and monitor in reducing certain amylase trypsin inhibitors that we're not reducing the ones that will also prevent insect infestation and potentially infestation from other pests like rats. And I think the challenge is that different wheat sensitivities are caused by different compounds in wheat. And so apart from amylase trypsin inhibitors, it's hard to breed for a wheat that's going to be better for everybody that has different wheat sensitivities. And I think fructans are a great example of the fact that if we breed for wheat with lower fructan content, that could benefit those with fructose malabsorption and IBS and potentially people with non-celiac wheat sensitivity. But it's going to be detrimental for individuals that use that as dietary fiber and as a prebiotic in the general population. And another challenge is with celiac in particular, the alpha gliadins that are very causative of these celiac effects are genetically linked to high molecular weight glutenins that are really important for baking quality. And so to have a wheat that's going to produce a great loaf of bread, you're probably going to reduce your high molecular weight glutenins in addition to these proteins that are problematic for individuals with celiac disease. So it's hard to get a variety that's going to bake well and also be better off for people with celiac disease. And then finally, I think our method of wheat variety designation and distribution makes this a challenge as well for breeding. That we'll take the example of the omega-5 reduced gliadin wheat. Great, we got this. That is going to improve wheat for a fraction of 0.4% of the population that has anaphylaxis and urticaria. But to get that variety to that target population, we do not track variety designation generally from farm to mill to market to consumer. And so we have this wheat sold in the marketplace that has no variety designation on it. We don't know what it is. And so how can we get these varieties that will be beneficial for certain populations, which is a very small population, to those target individuals? Breeding for celiac disease is particularly difficult. This study here by Mohlberg et al. Shows the reactivity in T cells from 8 different celiac patients exposed to proteins from different species of wheat, including durum, emmer, einkorn, and proteins from the D genome of common wheat. And you can see that einkorn and various emmer varieties, there are 3 varieties here, are on average quite lower in their intensity of reaction than common wheat. However, you have some patients like patient 5 who react highly to everything. And then you have some patients like patient 8 who reacted more intensely to one variety of einkorn than they did to the common wheat. So we have outliers here, and there's huge variability in these different patients. So if a variety is selected that overall reduces the intensity of celiac response, there are some individuals who are still going to be impacted quite a bit from those varieties. And so this kind of points out the general danger for releasing a wheat determined to be more celiac safe, because individuals with celiac disease should not be eating wheat at all. It very much endangers their health long term. And there are some people like patient 5 who will probably react to it nonetheless. So I think marketing that variety to consumers would be quite difficult. You'd have to educate consumers a lot to know what they're actually eating, so they wouldn't eat it on a regular basis. So next, how do processing methods impact wheat sensitivity? So most of these problematic compounds that cause wheat sensitivity are really difficult to break down in our digestive system. So they're proteins that we cannot hydrolyze very easily. They're fructans that we cannot digest. But the nice thing is that the wheat grain can do it for us. So upon germination, after imbibing water, the grain produces its own enzymes that begin to break apart these difficult proteins into smaller segments of nitrogen and amino acids that the seedling uses to grow. And so we can trick the wheat grain into breaking down these proteins for us and making them easier for us to digest. And germination, for example, after 7 days of germination, the omega-5 gliadins that are problematic for certain individuals with allergy were almost completely broken down. And so this germination is the most effective way to break down these difficult proteins. And next is sourdough baking, as you can see here. We have used fermentation for thousands of years, and the microbes that are used in sourdough baking, those lactobacilli bacteria, also produce enzymes that break apart these difficult proteins. So that's another way that we can reduce that exposure to those difficult proteins within our diet. And more than that, these lactobacilli bacteria lower the pH of the actual dough, which brings the pH to the optimal level for that enzyme activity to break down the proteins. So you have a two-way effective mechanism there of breaking down proteins. However, it takes a lot of time and a lot of heat, particularly in fermentation, to break down these difficult proteins. So this is kind of a schematic to show germination and fermentation time on the x-axis, and then the relative amount of these particular compounds that are left after that time. And prolamins here referring to those really difficult proteins that can become problematic for people with celiac disease and different wheat allergy and other wheat sensitivities. But there's a conflict of interest here for bakers that the top line shows the amount of prolamin degradation with fermentation, but this second line here shows the gluten macropolymer degradation, and the gluten macropolymer is this really important compound that we have in baking that creates the structural integrity of the bread. And so the fact is that it's easier for these microbes to break down than these difficult proteins. So the longer you wait, the less material you're going to have to make a good loaf of bread. And more than that, at the end, you can see that there are still some left. It doesn't go to zero. And so that's why these are still not determined as safe for individuals with celiac disease and wheat allergy. So we've reduced the amount, but those amounts are still there. Finally, there's different food additives that the industry has used, which have probably increased our exposure to these problematic compounds in our diet and in the general population. So wheat gluten, which are the storage proteins in wheat, is isolated by the food industry and called vital wheat gluten, among other names. And those proteins are also converted into new proteins for various functional properties in industrial food and called isolated wheat proteins. And these isolated wheat proteins and vital wheat gluten are added to many different food products for the sake of improving mouthfeel, boosting protein, because it's a very cheap source of protein, and emulsifying different products. And so you find these in different foods that would generally not contain wheat at all. And so here you can see about 86% of packet soups. We have about 61% of ice cream. You have, let's see, about 25% of vinegars and dressings and 21% of baby food in this wide grocery survey from Australia by Atchison et al. They found wheat within that many of the food products that were on the shelf. And as another food additive, inulin is used. And inulin is a type of fructan that can be added to foods for the sake of improving fat-free or low-fat food tastes and boosting fiber within the food. So inulin is not actually derived from wheat. It is derived from chicory root and Jerusalem artichoke, but it acts just like a fructan would act in wheat. And so the high prevalence of this additive really exposes the general population to these problematic fructans. And for individuals with irritable bowel syndrome, for individuals with non-celiac wheat sensitivity, and individuals with fructose malabsorption, these are particularly problematic. So what can we kind of draw from this? So first of all, no species of wheat is currently safe for individuals with celiac disease. There are varieties and species of wheat that produce lower reactivity. I will say, I don't know if you noticed in the celiac chart in particular, that modern and heritage wheat, they both have varieties that produce low amounts of these detrimental effects. And so I think targeting modern wheat only as a bad guy is probably not the way we should approach this situation. We just need to objectively be looking to find the material that's best for everyone. And I think to reduce accidental exposure, to delay disease epidemiology for celiac disease in particular, we can do a lot of things in finding these genotypes with low reactivity, and then use germination and fermentation processes more extensively in our food system, and then avoid this vital wheat gluten isolated wheat protein and inulin that we find within our food system quite a bit. So thank you for hanging with me with all of this difficult terminology. I can answer questions, but I do want to just put the caveat out there that I am a plant breeder and agronomist by training, and so this brings together many different disciplines, including medicine and food systems and food biochemistry, and so I'll do my best to answer your questions, but might not be able to take them all. So thank you.